Let's begin. Before going to today, we are going to start till now. Let me. Okay. Now, today we are going to we will study most important instrument will be one will be our meter bridge, and second will be potentiometer, and will very much important. You will see it is very much important. So meter bridge and potentiometer, and usually questions come from it. Okay. So before going to this two instrument, most important instrument, let us begin with some questions. Then we will go to that instrument. So take this question, try this question. I give you 10-second time, all of you. If you get any answer, then please write in the chat box. Try, all of you try. I give you 10-second only. Try this question just to warm up. I'm giving this question. Try this question. All of you try this question. Any answer? Any answer? Any answer? Any answer? Okay, let us see. Let us see. Not getting the answer, let us see. You see here, this potential. Will you try or I should do it? Will you try this question or I should do it? Okay, please interact. Now, let it be potential A, VA. This will be also potential VA. Yes. Yeah, great. This is spirit. Should have this type of spirit also. Use this concept, this VA, and suppose this potential is VB, then here potential will be VB. Okay. Now draw this, take 2 point VA and VB and join according to that. Between VA and VB, you see 6 ohm resistance. You see, we will draw like this. That is 6 ohm resistance. Now between this VA and this VB, there is also one 10 ohm resistance between VA and VB. We will draw one 10 ohm resistance like this. That is between VA and VB. Now between VA and VB, we are having one more resistance, 15 ohm, like this, and you can solve the answer. You will get the answer. Okay. Hi Mansu, if you are facing any problem, you are raising your hand. That's why I'm asking. Okay. I think you will do it. You all of can do it. Okay. I'm not knowing the answer. You solve it and you will get the answer. Okay. Let's move further. Take this question, try this. You should try this question. We'll discuss here only. Okay. You try this question. All of you try this question. Try this question. I give you 15-second time. Try this question. We will study the topic, but before that, let's go with some questions, because you know questions are more important in physics for your exam also. Any answer? Any answer? Okay, let us see then. Let us see. I give you one hint here. You should try it. Now, you have to find equivalent between A and B. How will you do? Start from A. You see here, from A, this 3 ohm resistance. Okay, one answer came. No idea, sir. Okay, nobody. I am giving you some hint. See, how will you do it? See, how will you do it? You see here, from A, we are having 2 resistors, 3 ohm and 3 ohm. Both are in series combination. You see here, both are in series combination. It will be 6 ohm resistance. Okay, 6 ohm, this 6 ohm and this 6 ohm parallel. 6 ohm parallel. It will give 3 ohm. This 3 ohm series. 3, 6. Again 6 in parallel with this. Again 3, 6. 6 parallel 3, 6 and 6 and 3 parallel. We will get 6 into 3. That is product of both of them and addition of both of them. What will answer? Answer will be 2 ohm. Any problem in understanding this? Any problem? Yes, no, please interact. Any problem? Or I should go by step? All of you got it? Again. Okay. I tell you again, once more. What I did, see, what I did, I am telling that this 3 ohm resistance and this 3 ohm resistance are in series. You see here, these in series. Okay, 3, 3, 6. You will get 6. Equivalent of this will be 6 ohm. This 6 ohm resistance and this 6 ohm resistance are in parallel. 2 resistance in parallel. Their resistance equivalent will be 3. 6 in parallel. Their equivalent will be 3. Okay. Now their equivalent will be 3. Now for this much of circuit, we got how much? 3 resistance, 3 ohm. Now this 3 ohm and this 3 ohm in series, we will get 3, 3, 6. Again 6. This 6 and this 6 will be in parallel. 6 and 6 in parallel. That means it will give how much? 3. Again, this 3 and this 3 in series, it will give 6. Now, this 6 and this 6 in parallel, you see, it will give 3. Now, this 3 and this 3 in series, it will give 6. Now, this 6 and this 3 in parallel, we will get equivalent of 6 and 3, we will get 2 ohm. Got it? Or still any confusion? I should do step by step. Any confusion? Till now, any confusion? Please write. Feel free to ask anything. Don't worry. If you want, I should repeat, then I will repeat it. Okay. All of you. Any problem to anyone? Any problem to anyone? Please interact. Any problem to anyone? Okay. Okay. All of you should interact. Okay. Now, let's move further then. Okay. Take this step, follow this step, you will get the answer. Okay. See this question. All of you, I give you 10-second time. Only 10 seconds. What will the answer? I think you know. Very easy question. Very easy question. By mistake, I have given this question. Very easy. Very easy. What will be the answer? What will be your answer? Yes. Sir, WhatsApp group है क्या? Himanshu, a WhatsApp group है. There is one WhatsApp group. I don't know about it. You should ask this from Ganesh sir. Okay, or IZ team. They will help you. Okay, I am not knowing about this WhatsApp group. Okay, मुझे नहीं पता है इस WhatsApp group के बारे में. आप इसके बारे में गणेश सर से या किसी राइजी की टीम से आप बात कर ले इसके बारे में. ठीक है, चलिए देखिए. तो ये दोनों हमारा पैरेलल में. What will happen? What will happen? It will be 10 ohm and 15 ohm by how much? In this we have multiplied and then added. This was 25, and again with series with it, you will get plus 12. Solve it and you will get the answer. Okay, very easy question. Now do this question. All of you do this question. Do this question. I will give 15-second time. All of you try this. Take 15-second time and try this question. All of you try this question. All of you try this question. Take 15-second time. Try this question. All of you try this. Any answer? Any answer? Any answer? Any answer from anyone? Okay, let us see what will happen. We have to find the resistance across A and B. A terminal is here and B terminal is here. You see, from this to this part, there is not crossing, but they are joint wire. Okay. Okay, let us see that. What will happen? This 10 ohm and this 15 ohm in parallel. Okay, what you will get? You solve it using parallel connection. That means 10 into 15 by 25. Addition of both of them 25. Here you will get one resistance like this, and its value will be this value. Now again, this and this in parallel. You will get one resistance. Okay, and it will be how much? 20 into 30 by addition of both of them 50. Now these both will be in series. You just add both of them, you will get the answer. Okay, okay, now all of you. Okay, now let's move further then. Okay, I think this question are very basic question, you should know. If you face any problem, you can ask. Why you are so much sleepy? Why you are not responding today? All of you respond. All of you, please respond. Please respond. Try this question now. Try this question. Try this question. All of you try this question. I think after this we will be starting topic also. You can see. Try this question. Take 15-second time and try attempt it. All of you try this question. Try this. Any answer? Any answer from anyone? Any answer? Okay, let us see. What it is telling, you have to find I. Okay, now how to solve it? Let us see. We know this I will go here. Now there is one problem. Option A. Okay, let me see what will happen. How? Let us see. How here one I ampere flowing through it, and we are getting a current division here. Okay, what we will do? We will see that you see one thing. This is see one trick. This is present. It is how much? It is 16 ohm. That means, just for your confusion, this is 16 ohm. This is also 16 ohm. That means I current will have two paths here and here, but in both of the path, the resistance is 16 ohm. That means I half of current will flow through this path and half of current will flow through this path. That means I1 will be equal to I2 and it will be equal to I by 2. We got a hint from it. Now I by 2 current flow through this, I by 2 current flow this. We have to find the I. Now what we will do? We know I by 2. Okay. Let us see. Okay. Let us see. I by 2 current flow through this, I by 2 coming from this, and here we will have it I. Now either we can write one KVL equation here. How we will write? Starting from here, we know we are moving this direction 10 volt. Now from here in this direction we know current is I by 2. We are moving direction of current. That means I by 2 into 16. Again in direction of current, we will write minus I by 2 into 2 equal to 0. Solve this equation, you will get the value of I. You can solve it, and I think you will get the value of I. I have done something wrong. You can see any problem. If I have done something wrong, you can ask. You can tell me. Okay. Done something wrong or not? All of you tell me. Some mistake I have done kya? 10 volt minus I by 2 through this path 16 and minus I by 2 through this path. Okay. Oh, here not minus I by 2. Here it is I into 2. Current I is flowing now here. Current I is flowing here. So we can write 10 like this, 10 minus I by 2 into 16 minus I into 2 is equal to 0. You will solve it and you will get I is equal to 1 ampere. Okay, good. Answer will be A. Good. Few of you have got answer A also. Good. Any problem till here? Any problem till here? Anyone? Any problem? Any problem? Anyone? Okay, okay. And I think all of you should interact. Now, let's take this question. This is last question. After this, we will be starting with meter bridge. Okay. So, try this question. All of you try this question. It is a good question. I will wait for your answer. Okay. I give you 30-second time. Try this question. Last question. Then we'll be starting with some topic. So, last question. Try, all of you try this. Any answer? Any answer? Any answer? Any answer? Any answer? Okay. Let us see how we can solve it. Okay, no worry. Let us see. Suppose we have to find potential difference across A and B, here and here. Okay. Now, what we will do? Let us suppose if there any symmetry, we try to find it. You see here this, and this, all three are in parallel. You see, and they are same, and their equivalent will be how much? 30 by 3. We can say 10 and 10 and 15 in series. We can say total R equivalent is equal to 10 plus 15. That is 25. Now, current flowing through this circuit I. How much? I will be equal to total EMF. How much? 3 volt by total resistance 25 here, and internal resistance is present here 5. You see it comes to be 3 by 30. This much ampere. Okay, that means 1 by 10. Okay, now we came to know that 1 by 10 ampere current is flowing through here. Okay, what will happen if you want to distribute current here? What you will do? You will say how much current will flow through this path? 1 by 10, 1/3 part will go here, 1/3 will go here, and 1/3 will go here, and though both will come, they all three will combine here, and we will get again 1 by 10 here. Okay, that's clear now. How much current to this path? 1 by 30. You see, to this path 1 by 30, and to this path it will be 1 by 30. Okay. Now, to find VAB, what we have to find? We have to find VAB. That means VA minus VB. I have told you one trick. What was it? Start from B. Again, I am repeating this. Start from B, reach A, and reach A. Start from B and reach A. What will happen? You have to start from B and reach A. No. Now, start from B. If you start from B, you see here we are moving like this, we are moving like this. One resistance came. Okay. And we are in opposite direction of current. You see, current is flowing through here. We are moving in opposite direction of current. What we will write? We will write VAB is equal to how? We will write minus 1 by 30 into 30 like this. Okay. Okay. But it will be positive because we are moving in opposite direction of current. We will reach here and reach the point at A. That means we will get here how much? We will get here 1 volt, and 1 volt will be our answer. Any problem to anyone? Option C. Yes, option C. Any problem? All of you got it? All of you got it, or any problem to anyone? Any problem to anyone? Okay. Okay. Or any problem, people, anyone? Okay. Okay, nice. Okay, Himanshu. Okay. Now, this is our last question. Okay, for today's warm up, we have got practice some question. Now we will start with our topic, theoretical part, and first instrument which we are going to study will be very important, and it is meter bridge. Let us start with our instrument called as meter bridge. Now, let us start with the meter bridge. What is meter bridge? Let me tell you what is. Yes. Meter bridge. Now, what happened in meter bridge? We in this meter bridge, what we do usually, we find the value of unknown resistance. Find value of unknown resistance. We find the value of unknown resistance. Okay, usually we do this. Okay, suppose here S is called as standard resistance. We know its value. It is a standard resistance, and this is R is unknown resistance here. Unknown resistance, and we have to find it. Okay. Now, this wire A to C, it is a standard wire. A to C is A to C. Let me take it. A to C. It is a standard wire, and it is of 100 centimeter length. 100 centimeter length. Okay. This point D, you see here D. This is called a jockey. It is called as jockey. What is jockey? It is a clip like thing. We move in this wire A to C, and where we get deflection in this galvanometer becomes 0. When this deflection becomes 0, we clip it here, fix it here. Okay. So what we do? We fix it at null point, and we say it as a null point. Null point, where the deflection of galvanometer becomes 0 or null, no value. Then we fix it here. Let us suppose we are moving here A to C, and we get null point at this point is called as D. Okay, null point here. And we know, suppose it is of 1 meter length, and parallel to it 1 meter scale runs here. Okay, through this meter scale we came to know where we got null point, and let it be L1 from A. Okay, we got L1 here, so we know it will be 100 minus, mistake here, 100 minus L1. Let us suppose when we buy when we buy any meter bridge, we have some value of resistance. It's called as RM. RM is value of resistance wire. Value of resistance wire per unit length. Per unit length. For per unit length, the resistance of wire is called as RF. Let us suppose we want to find resistance of A to D. What we will do? We know RM is the resistance of wire per unit length. We will multiply it with length of the wire A to D. We see A to D is L1. So multiplied here, we got value of RAD. Now we find resistance of D to C. What it will be? RM into how much? 100 minus L1. Okay. Now, since we have seen that it has got a null point here, that means it is based on which concept? It is based on balanced Wheatstone bridge. We have studied in our yesterday class. Okay. So balanced Wheatstone bridge, that means we can say at R, this one R by S is equal to corresponding resistance of here RAD by RDC, and we can write like this. RAD will be how much? It will be RM into L1 we have found, and RDC is RM into 100 minus L1. we came to it will get cut down, and R by S will be L1 by 100 minus L1. Using this formula, we can find the value of R. Okay, this R, and this is the value of unknown resistance. Okay, this is the working principle of meter bridge. And question comes, and this process only we take, and this use this formula, and we get find the value of unknown resistance. Any problem to anyone? We will solve some question, and we will clear our concept how it works. Till now, any concept, any problem, any concept, anyone, any problem? Okay, okay. All of you, any other people, any problem? Any other people, any problem till now? All of you should interact. Any problem to anyone? Okay. Very good. Now, let us move further then. Okay, let us move further then. Now, we are seeing on our next concept. It is a potentiometer. Very important. Potentiometer. Potentiometer. It is very important. Okay. Potentiometer. What is potentiometer? Usually, what happens in potentiometer? We have one wire, long wire, and it is called as AC. Let us suppose it called as AC. We joint it with one EMF. Let us suppose as E, and then we take one as a rheostat like this. Okay. Now one switch, and we connect it like this. This is the device is called as potentiometer. This AC wire, usually how we arrange it? We arrange like this. In a board, we arrange like this, AC wire. Okay. Different section, M1, M2, M3, different section. And what we do? We again move jockey here and find the null point. Okay. So potentiometer is a just electronic device which actually measures or compares EMF. Okay, it compares the EMF of two resistors. It compares the EMF of two cell. If we suppose we have to find the EMF of two cell, which is more EMF, which is less EMF, we will use potentiometer. Or if we want to find the internal resistance of a cell, then we use potentiometer. These two are famous application of potentiometer. Okay. Also, potentiometer can be used to find the value of potential difference, or that is voltage. We can find through it also. But these two are most important use of potentiometer. Okay. Any problem to anyone? In potentiometer, some terms are defined. Let me define some terms. It is called as phi. What is phi? Phi is called as resistance. Phi is called as resistance per unit length. That only which we were calling in that meter bridge. Similarly, we call it as resistance per unit length. It is called as phi. Okay. Similarly, if we want to find, suppose we want to find value resistance of A to C, what we will do? We will multiply this phi into length of AC. This length of AC, we will multiply this. We will get the resistance of AC. What we will multiply? We will multiply length of AC. We will get the value of resistance. Okay. Any problem understanding this? Anyone? Any problem? Any problem to anyone? Tell here. Any problem? Any problem to anyone? Tell here. Anyone? Oh, okay. I will explain it once more. Okay, no problem. What I told you, what is potentiometer? Just a potentiometer is a device, okay, which has a long wire, not having a meter wire, meter 1 meter only. It is having one long wire. Okay, let us suppose it as a AC. Okay, it is having some standard EMF, its own cell, and one rheostat and one key. Okay, we arrange this A to C wire, AC wire, standard wire in this format. You must have seen your class in your practical also. There is one like this, one wooden board, and in this wooden board, some wire are arranged like this. You must have seen a potentiometer. Okay, these are the potentiometer. Okay, wires of potentiometer. Okay, in this cell A to C, and there is one term defined as phi. Earlier we were telling as it as RM. You remember in meter bridge it was RM. Here we tell it as phi. What is phi? Phi is resistance per unit length. But that means for this wire, standard wire, we define phi. Phi is what? Phi is resistance per unit length. Resistance per unit length. Now, if we want to find the resistance of AC, whole wire from A to C, what we will do? We will multiply this phi into length of AC. We will get the value of resistance of AC. Okay, got it? Or problem remaining? Problem is there? Got it? Or still have problem? Okay. All of you, anyone, any problem? Other people, anyone, any problem? Anyone, any problem? Anyone, any problem? Okay. 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 Please interact. Okay. Now, let us move further. This is first application of potentiometer. First application is to compare two EMF. Okay. This is the EMF of potentiometer. But suppose I have two cells. Okay, I'm not knowing its EMF. I have cell 1 and cell 2. Cell 1 and cell 2. Okay, both are having different EMF, but I'm not knowing the EMF because I'm not having any rating of it. Okay, so to find the value of EMF, what we do? We use potentiometer. Okay, we keep two potentiometer arranged like this, and we take one switch. Okay, it is called as single pole double throw. Okay, we can either connect to 3 to 1 or 3 to 2. Okay, when we will connect 3 to 1, then current will flow through this path through E1. Okay, like this. When we will throw this to connect this 3 to 2, then through A2 through E2, current will flow through this. Okay, and we check, find where is the null point. Okay, now let me take this. If suppose I connect 1 and 3, 1 connected 1 and 3. I have connected where 1 and 3 like this. What will happen? I have connected, current will start flowing through this. After that, through galvanometer, one jockey is there. What I will do? I will move jockey through here or starting point. Okay, and I will find where it is getting null point. Suppose I got null point here, N1, first null point. Okay, then what I will do? I know that current will flow through this here like this. Okay, here like this, and through here it will go this side. Okay. Okay. Now, what I can say that if suppose I want to write the EMF equation, that KVL equation, what I will do? I will do like this. I will say, let me tell you, if in this case A and 1, we call it as L1. Okay. Now, I can tell like this. I have got null point here. I will say like this: E1 resistance minus, I can say like this, phi into L1 is equal to 0. I can say like this. See, I can say like this. You see what is phi? I have defined phi as potential. Okay. I think I have written here. Oh, resistance, not resistance. It is potential difference. Okay. It is potential difference. It is potential difference. I will write like this. VAC. Okay. What is phi? By mistake, I have written this. Okay. What is phi? Phi is potential difference per unit length. Phi is potential difference per unit length. So we will find, if we want to find voltage from A to C point, what we will do? We will find by this, multiply this phi into length of AC. Okay. Now, if we want to find the potential difference between these 2 points, and if suppose we are having this length as A, how much potential difference it will be? It will be V is equal to how much? A into phi. Okay, that only we will do. Now, using this, I can say like this: E1 is getting balanced by how? Minus how much potential drop from A to N1? How much potential drop? We can say phi into what is the length? L1 is equal to 0. That means we can say E1 is equal to phi into L1. Okay. Second case, if we have connected, tell me any problem? Anyone has any problem? Till here, any problem? Or getting confused? Any problem? Okay. Okay. Now what I am doing? Connected 3 and 2. All of you, if you have any problem, you can ask. Either you can tell me to repeat, I will repeat. Either any problem, you can chat with voice also, or in chat box you can write your message any way. Okay, please be interactive, it will be very much useful for you. Okay, now connected 3 and 2. If we are connecting this 3 and 2, we can write like this: E2 is equal to, current will flow through this path as a, through this path like this path. Let's suppose we got null point here, second null point like this here. We will write, let us suppose A and 2 is equal to L2. We will write E2 is equal to how much? Phi into L2. We can say like this: it is 1, it is 2. We take ratio of both of them. We will get E1 by E2 is equal to L1 by L2. Now, by finding the null point, as we get more null point, more length of null point, that means more EMF will be present for that cell. Okay, so here if we are seeing that second is having more value of more length of null point. After more length we are getting null point, that means E2 will be greater than E1. Okay, you see here E1 by E2 is equal to L1 by L2. Okay, that means directly proportional. Okay, more L1, that means more EMF. Okay, anyone, any problem? This is first application of potentiometer. We will take good question through it. But if anyone has any problem, you can ask. Anyone, any problem? Okay, all of you, anyone, any problem? Okay. Himanshu not responding. Why? All of you should respond. Okay. Now, this is the first application. Here we compare two EMF. Okay. Okay. Now we will any Himanshu, are you getting Himanshu? Himanshu, are you getting? Okay. Okay. You can ask now. Let us move further. This is second application. Okay, second application of your potentiometer. Second application of okay, Himanshu, you should respond. Okay, Now we have to find, suppose we have to find the internal resistance of it. Suppose we are having this E and we have to find the internal resistance of it. What we do, we connect it here. Resistance box is just a combination of resistance we have put here. Okay, all internal resistance, external resistance, we put it here and we call it as a resistance box. Okay, and we call it as a resistance box. Okay, suppose what we do here, we take here, okay, we take here, we have, suppose we are, there are two things. What we do, we first of all, case one, what we do, K2 is open. K2 is open. What will happen? Current will flow through this path. Okay, to this path, what will happen? We see if K2 is open, what we will get? We will get E1 is E is equal to 5 into, let us suppose L1. See, L1 length when K2 is open. Okay, now K2 is closed. K2 is closed. Suppose now we have closed K2. What will happen? Current will flow through this path, and we are getting, suppose here our null point, another point. Okay, what will happen? Current will flow through this resistance box also and through this cell also. So after closing this switch, we will get next voltage and we will call it as a potential difference, and we will say it as like this, phi into L2. We have assumed A and 1 like this. A and 1 is equal to L1, and we have assumed A and 2 is equal to L2. We have assumed like this. Now we also know I is equal to how much I will flow. Today we have studied total EMF by total resistance, that is R plus R. This R is external resistance and this R is internal resistance, and both are included in this resistance box. Okay, this much. And also we know that if I is equal to this much, we know V is equal to how much? V is equal to I into R. We can say E by R plus R into R, and also it is equal to phi into L2. We have got here. Also we can write value of phi like this. From here, what will the value of phi? From here we can E by L1 into L2 like this. Now use this equation and this equation and solve both of them. Okay, what I am telling? I am telling solve both of them. What you will get? You will get R is equal to R into L1 minus L2 minus 1. This will be the value of internal resistance. Okay, any problem to anyone? Okay, okay, only one thing you have to remember. What you have to remember, that the numerator we have taken L1. You see here, in numerator we have taken L1. When we get L1, when K2 is off. When we get L2, when K2 is on. Okay, this formula only use and solve the question. Anyone, any problem? Anyone, any problem? Anyone? Should I repeat? Okay, okay, okay. All of you, anyone, any problem? Okay. Okay, okay. Let us see then. Let us see. Now, we see it and we are going to start with some question. Okay. We have gone through that meter bridge. Okay. We have seen what? Meter bridge. Okay. Meter bridge. We have seen potentiometer also, and two of its application which are very frequently asked. One more thing, I tell you one more thing. Sometimes some question comes in your exam to increase the sensitivity. I tell you, because objective question may come, sensitivity of potentiometer. If we want to increase sensitivity of potentiometer, what we have to do? First important thing, what we do to increase sensitivity, we have to increase this value of potential drop of 5, this value of 5, we have to increase this. Okay, first of all, what we have to do, we have to increase this. Okay, we increase this to increase sensitivity. Okay, second, what we do, we decrease the current value by using resistance box. These two things we do usually, okay, to increase the sensitivity of potentiometer. Any problem to anyone? Any problem? Okay, these are just a point to remember. Just point to remember. Nobody just point to remember. Okay. Okay, just is it a point to remember. Okay. So let us move further then. Now take this question. Solve it. I will give you 10-second time, all of you. Try this question. We are going through some questions now. Try this question, all of you. Try this question. Try this question, all of you. Try this question, all of you. Any answer? Any answer from anyone? Any answer from anyone? Any answer? Okay, let us see then. Let us see. No worry. Let us see. Let us see. What is it telling that? It is telling that length AB for null deflection. Okay, we are getting null deflection here. It is telling that we are getting null deflection here. And it is okay. Let us see. It is telling it is having null deflection here. So what we can say, null deflection means here it is balanced. We can say like that. We will take the ratio of both of them. Okay, we can write like this: 15/10 is equal to, we know, let us assume this value and say it x. We can write like this: x by 100 minus x. Solve it and you will get the value of x, and x will be your answer. Okay, simple question, very simple question. Got it? Any problem? You can solve it now. Can I move now? What happened? What you will get from here? 300 minus 3x, 300 minus 3x is equal to 2x. That means 300 is equal to 5x. Okay, 60. Okay. Okay. Now let's move further. Try this question, all of you. Try this question. Try this question, all of you. I give you 30-second time. Try this question. All of you try this question. All of you try this question. 30-second time. Take 30-second time. Try this question. Any answer from anyone? Any answer? Anyone? Any answer? Anyone? Any answer? Try this, try this. 10 seconds or more. Try this, try this. All of you try this. Okay, now let us see what is given. It is given that in a potentiometer, internal resistance of a cell and EMF E is to be determined. Okay, it is given that internal resistance of a cell R, internal resistance R of the cell E. We have to find the value of internal resistance, and also given that K is open. That means K is open. Remember, in our formula K is open, we get L1. I have told you now, it is obtained at 60. That means it is 60. And when K is closed, I have told you, we get L1 now. I have written there L2 also. We can write like this: L2 is equal to how much? It is given as 50. We have to find value of R. You see here, simple circuit. This is RB, resistance box. This is standard resistance, and it's this is standard EMF and standard resistance. We have to find the value of this R. Okay, what we will get? We know formula of smaller. What it is? It is R into what we get, L1 by L2 minus 1. We can solve like this. How much? R is 10. You see 10 into L1 when K is open. Open means 60 by 50 and minus 1. You will get this answer. This much centimeter, I think. Any problem? You can solve it. Any problem to anyone? Anyone, any problem? Okay. You can solve it and you will get the answer. Okay. You can solve it and you will get the answer. Okay. Now, let's move further. Okay. Let's see the good another question. Okay. Try this question. All of you try this question. I give you 20-second time. Try, all of you. Try this question. Take it seriously. Try this question. All of you try this question. Try this question, all of you. Try this question, all of you try this. Any answer? Any answer from anyone? Okay, let us see then. Let us see then. Okay, let us see. Let us see. It is telling that we are having a potentiometer arrangement and cell of EMF is 1.5 and gives a balance at, that means for E1, that is 1.5, L1 is given. Okay, and again it is replaced by another cell. Let it be E2. For this E2, we get L2, and L2 is 50 centimeter. L2 is 50 centimeter, and L1 is, you see here, and L1 is how much? 3 centimeter. And we know this formula of comparing the EMF, that was E1 by E2 is equal to L1 by L2. We can write like this: 1.5 by E is equal to, corresponding to 1.5, L is 3 and this 50. Solve it. You will get the value of E and it will be your answer. Okay. All of you okay now? All of you? Yes, no? Write something, yes, no? Okay. Doubt? Shall I repeat it once more? Okay. And that Himanshu is not responding. Why? Himanshu respond. You should also respond. Now, take this question. Try this. I will wait for your answer. Try this question. Try this question. I will wait for your answer. Try this question. I will wait for your answer. Try this question. Try this question, all of you. Try this question. All of you try this question. I will wait for your answer. Try this question. All of you try this. Any answer? Any answer from anyone? Any answer? Any answer from anyone? Anyone? Any answer? Okay, one answer came, I think. 2 ohm. Okay, let me see. It is telling that we are having 2-volt potentiometer and it is used for determination of internal resistance of our cell. This okay, and it's telling that when K is not inserted, you see K open, we get L1. You remember the formula? L1 is given as 60. You see, when K is closed, we get L2, and L2 is 50. You see here given, and we know R is equal to total resistance R, what? L1 minus L1 by L2 minus 1. What you will do? You write here value of R. R is how much? R is how much? R is, we are knowing something given or not? You see something given or not? You see something is given in here. Figure shows potentiometer for determination of this transition. When K is not inserted, a balance point is 60, and when K is closed, balance point is here. You see the value of R is not given, but you can see right like this. You can see here it is not given, but I think some mistake have been done in typing this question. Some internal I see. Okay, what we have done R, okay, let me put the values. L1 is 60, L2 is 50 minus 1, and the value of internal resistance. Okay, what we will do? Okay, resistance, okay. It is not inserted. What is telling me not inserted? Okay. I think some data are missing here. It is telling that 2-volt potentiometer used for determination of internal resistance of this much volt. When K is not inserted, this much L1, L2, then we need external resistance R, but not given that external resistance. What we will do? We can write like this also. Not possible. We know one more thing like this. We know one more thing also like this. Okay, okay, let me see. Oh, yes. Okay, good, thank you. It is given as 10. Okay. Nice. We can solve it and you will get the answer. Thank you for suggesting. Thank you. Okay, you will put the value and get the answer. Okay, all of you getting now, all of you clear? It's clear now. Potentiometer, meter bridge, clear? Okay, now okay, good. Let us take another question. I think one more question. Okay, we should try this. Now I will wait for you. I will not help you, anyone. You have to find. Now I will wait for your answer. Okay, practice of yours. Try this question. Take 15-second time and try this. Give me your answer. What will you get? Try this question. All of you try this question. Try this question, all of you. Try this question. Any answer? Any answer? Anyone? Any answer? Any answer? Any answer? Anyone? You see here. Okay, so answer came. Option A. Okay. I think you must have done like this. Okay, you assumed here X. You assume there suppose L, it will be 100 minus L, and then balanced it. The ratio of this by this is equal to this by this, and you solve it. Okay. Okay. Now I will not do it. Okay. These are your homework, so you should do and solve it. Okay. Now let's move to a second question. This question. Here also I will not help you anyone. Okay. I will not help anyone. You should do it. Take this as your homework. Try this. If possible, you can find here also. Tell me what you will answer. Try this question. Any answer? Anyone? Any answer? Okay. Try this question. You should try now. Okay, I give you some hint. Okay, I give you some hint. It is telling that a potentiometer of wire having 10 meter long stretched on it to have to connect it to a battery having a steady voltage. Okay, no confusion. It is only telling that battery is having constant voltage. Okay, if not given also we assume it. Okay, one type of cell. Okay, okay, don't get confused. Okay, like that Daniel cell, galvanic cell, like this also one cell. Now this cell gives a null point at this. That means for E1 we get null point at 750 centimeter. If the length of potential wire is increased by 100 centimeter. Now what we are doing, we are increasing the length of potentiometer wire by 100 centimeter. What will be the new position of a null point? You remember what was the concept of potentiometer? Okay, you know, when we are connecting it with one cell, okay, we are getting we are getting null point at 750 centimeter. Okay, okay, power shortage from my side. Okay, I think you should do it. Okay, take it as a homework. Take it as a homework. Okay, and you should try this question. Okay, try this question. You can do it. Revise the lecture once more, and I will. You can do it. If you will not get it, first of all, we will solve this question and begin our tomorrow lecture. Okay, you should try this question first. Okay, okay. Try this question. Okay, good, very good. You should have spirit, such type of spirit also. Okay, okay. Power shortage from my side. Okay. Now take few example. Take this question also as your homework. Take this question as a homework. Take this question as a homework. Okay, you can do it. You think, you see here, not getting any confused. This is a potentiometer wire. Okay, you do it. You can do it now. Try this question also as your homework. If you will not able to do it, then we will discuss it tomorrow. Okay, okay. This is your homework. Now take one more homework. This also. This also take this your homework. It is also easy question. This is your homework also. Okay, revise the lecture once and then go through it. If you will find any problem, please before starting the tomorrow's lecture, you should remind me that this question, or you should write any one of the letter. I will discuss the question first and then we will go to then you will go to the solution. Then we will move further. Okay.